All right, today we're taking a look at review day number 9, talking about area, a little bit of surface area, a little reference to the lateral area. So in terms of surface area, we talked about this during the year, but really for the exam, we just kind of want to consider the fact that surface area is just the area of all the surfaces. So if you have a prism, you can just find the area of all the outer sides and just add them together, okay? If it's a cylinder, we want to keep in mind that a cylinder, right, has a circular top and bottom, and then connects together. So if we were to cut this apart, okay, it would turn into two circles, and then a rectangular portion that would become like the wrapper, so to speak. So remember that this portion at the top here is really the circumference, which is 2 pi r, and then this part is the height of the prism. And then we would just need to find the area of these two circles, which we know is just pi r squared. So the lateral area is 2 pi rh, and the surface area is 2 pi rh plus the two circles, 2 pi r squared. Okay, so 2 pi rh is the area of this rectangular piece, and then the two circles for the surface area. A cone, similarly, right, looks like kind of like a triangular but a circular base. So when you cut it open, you're going to get the circle, and then you're going to get what kind of looks like a triangle, but it's going to be rounded at the bottom. Now, just like the area of a triangle, right, it has a base and height. The base, right, is actually the circumference, and then the height is called the slant height. That's that lowercase cursive L that we talked about at the beginning of the year. And when we know the circle is just pi r squared. So when you're doing the surface area, okay, it's 1/2, right, like a triangle, 1/2 base times height. The 1/2 and the 2 are going to drop out, so it's going to be pi r l plus the circle on the bottom, which is pi r squared. And this is the lateral area, just pi r l. The sphere is just 4 pi r squared. So really, these are the three formulas you really need to know in terms of surface area. The cylinder is 2 pi r h plus 2 pi r squared. The cone is pi r l plus the area of the circle, pi r squared. And then the sphere is just 4 pi r squared. So if you're answering a question with a prism, just find the area of all the sides and then just combine them together. Okay, so we take a look at number 181 here. Kiera had a square poster. The framing was placed against a wall. The poster had a diagonal of 58 centimeters. The key thing here is that it's a square poster, okay? And it fit exactly inside the frame. The width of the frame around the picture, okay, is 4 centimeters. Determine the area of the poster and the frame. So the area of, like, if this was one solid piece, what's the area of the whole thing? So what we really need to do for this question, if you think about it, so pause it and see if you can come up with your own method solution. Okay, so hopefully you recognize we just need to figure out what this length is right here. Because if we know the length of this, ultimately we just need to figure out the length of this side, right? The whole thing here. So if we can figure out that length, which we can call x, then all we're doing is adding 4, right, onto each side here. 4 here and 4 here. So this side is going to be x plus 8. And in order to figure out the area of this entire thing, I just do length times width, or side squared. And this side is also x plus 8. So I'm just going to multiply these two sides together. All right, now the inside of this, because it's a square, is made up of a right triangle, okay? And we're just looking for these two sides, x and x. And so we can use Pythagorean Theorem to get those. So if we do a squared plus b squared is equal to c squared, we can do x squared plus x squared is equal to 58 squared. All right, so x squared plus x squared is 2x squared, 58 squared. Pause while I check on the calculator here. All right. Okay, 58 squared, and then 3,364. And then we're not going to square it yet because we don't have the squared term by itself. So we need to get rid of this 2 in front because it's not being squared. So x squared is going to equal, what do we get when we divide this by 2? Which is 1,682. And then we're going to take the square root of that answer. and we get 41.0121983. So that is what we're going to get as a result. So 1682 here, and then square root that to get x. And so it says nearest tenth, and we're just adding 8 to both of those. So for right now, we don't want to do the nearest tenth. The area is the nearest tenth, not the side length. So we're going to kind of write this out. So it's 41.02012, apologies, 1933088. 9333088. That's the number I got. Now, that means that this piece, if we add 8 to it, just turns into 49.01219333088. Now, that's what x is. So when you're doing this, if you just need to write the formula for the area, you can just do x times x. And since we've called x 0, so I just finished that, we're just going to multiply that together. So the area is equal to x plus 8 times x plus 8. Okay, we could just write that, or we can just put this number here, 49.01219333088 squared. Okay. So we're just going to take this number, we can add 8 to it, and then we're going to square it. So notice that I'm using that long number, and now I'm going to round it. So 2,402.2. Okay?
Yay!
And that is our answer. And it is in centimeters, so the area would be in centimeters squared, but that is already implied because it's written in squared centimeters. So if you didn't write it, you wouldn't lose points for this question. Okay, 182 next door. Go ahead and try this one, and then we'll go over it together. Okay, so we had approximately 450 feet. We have a gallon of paint that will cover approximately 450 square feet. We want to paint the outside surfaces of this cube, which has sides of 12 on each edge. So really, all we want to do is figure out if we painted just this one side here, there's 6 of them. So if we find the area of the side, we just multiply times 6 because there's 6 sides. So 12 times 12 times 6 is 864. And then we just need to take that, which is cubic feet, or square feet, sorry, because it's area, and we're going to divide that by 450, because that's how much one can of paint covers. So if we divide this out by 450, now if you just hit enter, it's going to give you a fraction. So instead, you can either press Control Enter or put a decimal point with one of these numbers. And as long as there's a decimal point there, it will always give you the decimal answer. So you can remember that as you're working along. And since we need 1.92 cans, right, this is the number of cans, we can't buy 0.92 of a can, so we're going to have to round up and say that we need 2 cans of paint. Okay, number 185, Francisco needs 3 pieces of glass shown below on the stained glass window. The shapes of 2 triangles in the trapezoid are measured in inches. Now, we can have a glass sheet that is 12 inches wide. And what we want to know is if it's 12 inches wide, how many inches in length do we need? Now remember, if you're cutting pieces out of a glass, what is it really asking you to do? So see if you can figure out this one. Pause it, see if you can come up with a plan, and then we'll go over it. Okay, so since you've had time to think, remember, all we'd have to do is cut these pieces out of this. So if we could, like if we cut this out of, okay, this glass, right, do we have extra pieces left? And if we do, can we use these pieces to make this? And what you might notice is that these triangles, right, all have a length of 12 and a side length of 15. So it is possible, okay, to combine these together. And we're going to flip it again, just so you get the idea here. And we could like cut that out here, and we could do the same thing with this one. It can fit right there. And so all we have to do is just kind of piece these together, and you can kind of get the idea that this side right here, right, going all the way across, was 20, and this last triangle, it's kind of neat, it actually fit right there, okay? And so since these pieces, this triangle goes here, okay, has a length of 9, and this one, cut it out, has a length of 5, that this is a length of 20. And that is our answer. Now, the other thing you can think about is that what I'm doing when I'm cutting the glass is I'm actually calculating, right, the area of the glass needed. So if I calculate the area of the trapezoid plus the area of the triangles, we'll call this 1 and 2, right? Then I already know that these all have a height of 12. So if I divide up the 12, that'll give me the length. So if we do 1/2 the height, which is 12, times the sum of the bases, which is 6 plus 20, plus 1/2 the base times height, which is the legs, so 9 times 12, plus 1/2, once again, right triangle is just the legs of the base and the height, 5 times 12. So half of 12 is 6 times 5. This is an area of 30. Half of 12 is 6 times 9. This is an area of 54. And then this one's going to be 13 times 12. So let's see, that's 144 plus another 12. So 156. You can also just type this right on your calculator. So 1/2, right, times 6, or sorry, the height was 12, times 20 plus 6 plus 1/2 of 6 times 12, right? We say 6 times 12? 9 times 12, sorry. Plus 1/2, and then this is 5 times 12. And we'll hit enter, and there's the answer, it's 240, okay? So you can type it all in your calculator, all right? This is going to be the area, the total, and so if we just take the area and divide it by 12, which is the height, that'll give us the base, okay, or the length. So 240 divided by 12 is equal to 20, and that's another way that we can get the length. All right, arc length. So the formula we actually used in class for arc length, okay, was actually a ratio. And so what we did was we did the arc length over, now the arc length is a piece of the circumference going around the circle. So if we do a ratio of the piece of the circumference to the whole thing, then we can make a ratio of the angle measure to the whole circle, and those should be equal. So arc length over the circumference, which is just 2 pi r, is equal to the angle at the center, the central angle, over the entire circle, which is 360. This is all you have to do to answer these questions. So if we look at number 188, the measure of the angle is 120, the radius is 6. We want to know what's an expression to represent the length of the arc. So if we follow our formula, we're going to do arc length, which we don't know, that's x, over 2 pi times 6 is equal to the angle, which is 120, over the entire circle, which is 360. Now your calculator, good news, okay, will just calculate or reduce for you any fraction you put in if you just hit enter. So 120 over 360 is just a third. So this is equal to 1/3, and this becomes x over 12 pi. And so if we just cross multiply and solve, we're going to get 3x is equal to 12 pi. So 3 times x, 12 pi times 1, okay? And then we divide by 3 to get x by itself. Ooh, that should be a pi, not an x on the 12. Got a little too x-happy there. And we're going to get x is equal to 4 pi. Now, that is the length of this arc, okay? So which of these is equal to 4 pi? So remember, this is 1/3, and then 1/3 times 6 is really just 2 pi, so that's not it. 120 times 6, that's 720, that's too big. That's not it. 1/3 times 36 is 12, so that's not it. And 1/3 times 4, or times 12, that is 4. So that would be 4 pi. That would be our choice. Okay, number 190. In the diagram below, circle 1 has a radius of 4, while circle 2 has a radius of 6.5. Angle A intercepts an arc length of pi, and B intercepts an arc length of 13 pi over 8. Dominic thinks the angles A and B have the same radian measure. Now, we mentioned radian measure in class today, and we talked about the fact that radian measure has a conversion where pi radians, okay, pi radians, that's the number of radiuses it takes to get around the circle, is the same as, okay, 180 degrees. These two things are interchangeable. All right, so as long as we can show the angle measure is equal in degrees, we can state that the radian measure is going to be the same thing. And that's what we want to show. So if we use our formula, okay, for arc length, remember it's arc length over the circumference equals angle over 360. Now, in the first circle, the arc length is pi. So we already know, okay, for this question, let's try this again. Hold on, need to find the little selector. All right, circle 1 has a radius of 4, okay, and intercepts an arc length of pi. On the other circle we're talking about, circle 2 has a radius of 6.5 and intercepts an arc length of 13 pi. So let's keep that in mind, okay? All right, come on, you're killing me, small. Like, there we go. Okay, so once again, pi over 2 pi times 4 is equal to the angle, which we'll just call A, over 360. Now remember, the pi over pi just gives us 1, so these two are going to cancel out. And what's left, if everything's gone, there's still a 1 left over. There's always a 1 in that spot when all the numbers are reduced. So it's 1 over 8 is equal to A over 360. And then we can cross multiply. So 8 times A is 8A, and 1 times 360 is just 360. And then we divide by 8, and we're going to get an answer of 45 to equal A. So if we get the same thing for B, then we know the angles are equal and the radian measure has to be the same. So once again, arc length is 13 pi over 8. So we're going to do 13 pi over 8. We're going to divide that, not over pi. Now there's too much pi. We didn't have enough of it last time. Now we have too much. Over pi times 6.5, right? And it's arc length, so it's 2 pi r, not pi r squared. Okay? And that's equal to, we'll say, B over 360. Now, this is a little crazy over here. But remember, our calculator will reduce it for us. So if you want to just hit Control Divide, that'll give us a fraction bar. We can do 13 pi, okay, over, and remember what's on the bottom is 8. And if you hit Enter, that'll give you the decimal answer. So that's the number of radiuses that it takes to get around the circle. And we're going to divide that by 2 times. Now remember, we want to divide it by the whole thing. So if we do 2 pi times 6.5, we're going to end up only dividing by 2 and then multiplying times pi and 6.5. So what we have to remember to do is to put parentheses around this part, not that part. This part. So now we're going to do 2 pi times 6.5 here. And notice now the whole thing goes to the bottom instead. And we get 0.0 or 0.125. So this whole thing just reduces down to that decimal. And that's equal to B over 360. So if we put it over 1, we can just cross multiply. We're going to get 1 times B, which is just B, and 0.125 is times 360, so we just have to multiply our answer here, times 360, and we get 45 again. Okay? So remember, we want to explain why. So we're going to say, yes, Dominic is correct Okay, since both angles are 45 degrees, they are congruent, and we'll have the same radian measure. All right, we can add as well. So once the angle's equal, whether it's degrees or radians, it's going to be the same thing. Okay, we went over this first thing today, which is areas of sectors. So remember, just like last time, the formula is the same except we use this area formula instead of the circumference. So for our purposes, we can either use this equation right here, or, okay, we can use our formula, which is the area of the sector over the area of the circle, which is pi r squared. So instead of circumference, we're using area. It's once again equal to the central angle over 360. We're just going to use that formula and type it in. So the first one, we have a radius of 8. We have a central angle that's given to us at 360, but we actually want the other way around here. Okay, so this, if it's 360 there, it's 300 here. So remember, we use our formula. It's going to be the area, which I don't know, over the area of the circle, which is pi times 8 squared. And that's equal to the central angle, which is 300, over
360 something.
over 360. And so once again, we can reduce. So x over 64 pi, we can type in 300 over 360 and let it reduce it for us, which is just going to come out to 5/6. Okay? And then we're going to cross multiply. So 6x, we multiply across the way here, is equal to 64 times 5 with a pi attached. So just 54 times 5 first. That's 320. And then remember, we're going to end up dividing that by 6 because there's the 6 on the other side here. Okay, so 320, and then divide by 6, and we're going to get our answer. Now, when you type in divided by 6 and hit enter, it's going to reduce it for you. And remember, there still was, we multiplied by 6 here. This is 320 pi, okay? So when we reduce, we're going to get 160 pi over 3. The fraction is just the coefficients. The pi has to stick around like a variable. And there's our answer. All right? Now, you can also kind of see that this is more than half the circle, right? So keep that in mind.
Okay.
When you're doing that, okay? So if you saw an expression here that's less than half, we wouldn't want to pick it. All these are more than half, though. All right, 192. Try this one on your own here, and then we'll go over it. Okay, so you should have started off with x over pi times 5 squared equals 360, or 30 over 360, which reduces down to 1/12. We can cross multiply here. So 25 pi is going to equal 12x. And then we just divide it by 12. So 25 pi divided by 12. No need for parentheses here since the 25 pi is on the top. We know what order of operations is going to make to go first. And we're going to get 6.5 for our final answer. Okay, we're going to do 202 first, and we'll come back to 197 because it has that radians again. So try 202 first, and then we'll take a look at it. Okay, so going through it, you should have set up our ratio. So x over pi r squared, angle over 360. So 4.5 squared here is going to be our radius.
Radius is going to be our
So
radius.
square it, you get 20.25 pi, and then this reduces down to 1/9. So cross multiply. Okay, 9x is equal to 20.25 pi, and then just divide out by 9. So since you're going to the nearest, it does say in terms of pi, we're going to leave the pi out of it and just divide the 20.25 by 9 and leave the pi attached. So x is 2.25 and then the pi. And this, remember, is in units, and it doesn't give you units. So you don't have to put them, or you can write U for units or anything like that, but that would be our answer. Okay. Now, 197. So here's the deal with radians, okay? A radian is just a distance traveled around the circle that is equal to 1 radius. So if this length is a radius, then if you travel around the circle, r units, okay? You're going to create kind of a piece of pizza here, and this angle that we're talking about here is referred to as a radian. Okay? Now, we already know that when you go around the circle, the formula for that is the circumference, and it's 2 pi times the radius. So if you travel r units at a time, you will have gone 2 pi units of r to go around the circle. So there's 2 pi radians in a full circle, okay? That means if you go all the way around the circle, 360 degrees traveled has to equal 2 pi radians. So if we divide by 2, this is our conversion now. We're going to know that 180 degrees is equal to pi radians, okay? And a radian, if you think about it, is that's like a semicircle, okay? So how many radii would you need to travel to get around the circle? Well, remember, if this is the radius right here, I need 1, 2, 3, and just a little bit more. That's what pi is, 3.124, right? So it's just more than 3 radii to get around the circle. So what we're going to do is to answer this question, because it says it wants the measure of the angle in radians, is we're going to convert this to degrees, okay, first. Now, they've only asked 2 questions with radians on every single geometry exam ever. So it's not something that comes up often. All right, and all you need to do is remember that to convert from degrees to radians, we just have to plug 180 in wherever pi is. So number 1 would be 180 over 3. Number 2 would be 4 times 180 over 3. Number 3 would be 16 times 180 over 3. And number 4 would be 64 times 180 over 3. Okay, now remember, if you're doing the measure of the area or the angle here, we're not going to go around the circle more than once. So we shouldn't pick anything that's bigger than 2 pi, because that's the most we're going to have in terms of radians. So these two are kind of going to be too big, all right, because they're way bigger than 2. But we'll get there. That's just a thinking question. So if we type these in, we're going to get what this is in degrees. Now 180 divided by 3 is just 60. So that's pi over 3 is equal to 60 degrees. Okay, 4 times 180 is 60 really, times 4, so that's 240 degrees. 16 times 180 divided by 3, okay, is 960 degrees. And then 64 times 180 over 3 is 3,840 degrees. So all we need to do is figure out what the angle is in terms of using our area of the sector that's given and the diameter, which is 32. So that means the radius is 16. We're going to use the same formula we used before. The area over pi r squared is equal to the angle over 360. Okay, and then we just got to cross multiply and solve. That's it. So all we're going to do is plug in. So the area, I know, is 512 pi over 3. We're going to divide that by pi times 16 squared. And this is equal to the angle, which I don't know, over 360. So remember, we typed this in our calculator to reduce. So we're going to do 512 you go away. 12 pi divided by 3. You can hit enter for the decimal. And then we're going to divide that again, parentheses now, by 16. Remember, it's pi r squared. So if you want to put the pi first, that's fine. Pi times 16 squared. And we get 0.6666 repeating. And if you want to convert to a decimal, we go to menu. Then we're dealing with a number. Okay, notice it has a little fraction to decimal, so that's how we're kind of keeping that track. Okay, approximate to fraction, and we get 2/3. So this whole thing is just equal to 2/3, and that's equal to x over 360, and then we can cross multiply and solve. So once again, 3x is equal to 2 times 360, which is going to be 720. And then when we divide by 3, we're going to get x is equal to 240. And since that matches that number of degrees, our answer is choice 2. And that is arc length, radian measure, and surface area in a nutshell. If you have any questions, let me know. Otherwise, we'll see you tomorrow.